Adam Taylor, the founder of Aduvo Engineering Training and the author of the Microset Chronicles. Over the last 10 years, the Chronicles have examined many aspects of AMD FPGA and SoC technology and how to use them effectively in your application. Over the next few minutes, if you have them, I would like to talk about something which pops up often with our clients, and that is how to select the right FPGA or SoC from the Cost Optimized Portfolio. If you are not familiar with the Cost Optimized Portfolio, it includes devices in both the 7 Series and UltraScale Plus ranges. In the 7 Series, the Cost Optimized Portfolio includes Spartan 7 and Arctic 7 devices. The Spartan 7 devices offer developers the lowest cost and smallest packaging, along with the highest logic to I/O density, while the Arctic 7 range offers multi-gigabit transceivers capable of up to 6.6 gigabits per second. If embedded processing is required, within the 7 Series, the Zinc 7000 devices from the 7000S to the 7020 provide developers with single or dual-core ARM Cortex-A9 processors and programmable logic. The UltraScale MPSoC families provide developers with either dual or quad-core A53s. Within the UltraScale Plus range, the Cost Optimized Portfolio also includes the Arctic's UltraScale Plus devices with transceivers capable of supporting line rates at up to 16 gigabits per second, along with the UltraScale Plus MPSoC families in the ZU1 to ZU3T devices. The Cost Optimized range is an ideal starting point for many projects as it offers the ability to perform system integration. We can combine several features into a single device, reducing the BOM and the required board area. This integration also reduces the technical risk as the board design is simpler, which reduces EMC, EMI, potential issues as well. The Cost Optimized Portfolio also provides, as we will see, a range of architectural flexibility depending upon the needs of the application and depending on the mix of sequential and parallel processing. We can select a heterogeneous SoC which comes with a hard processor core or an FPGA with a soft processor implemented in the fabric. With both SoC and FPGA solutions, we get a wide-ranging interfacing capability which can be used to implement standard, legacy and bespoke interfaces, freeing us from the constraints which might exist in other solutions. If we select a SoC-based solution, we are also able to offload processing bottlenecks for acceleration into the programmable logic using high-level synthesis. But how do we go about selecting the correct cost-optimized portfolio device from the possible range? There are several selection points and decision points which we can use depending upon the demands of the application. And the first of these is, does the application need an embedded processor? If yes, this means we need to select from the Zinc 7000 or the Zinc MPSoC devices. If not, then we have narrowed our selection down to the Spartan 7, Arctic 7 or Arctic's UltraScale Plus devices. Following on with the decision tree, if our application does need a processor, a further decision point can be if gigabit transceivers are needed in the programmable logic. If programmable logic transceivers are required, then the best cost-optimized portfolio device is the UltraScale Plus ZU3T. If PL transceivers are not required, the selection point becomes one of the required logic density. If that required logic density is greater than 80,000 LUTs, the UltraScale MPSoC should be considered. But as we are talking about logic density, a little word of caution. It is worth remembering that when sizing logic resources throughout a project lifecycle, there is often scope and requirement changes, and that leads to an increase in required logic resources. It's therefore a good idea to size the device to be approximately 60% full when the initial size estimates are completed. This enables room for design growth while we also lower the risk of implementation and timing closure issues as that size increases throughout the life cycle of the project. If embedded processing is not required, it must be determined if transceivers are required or not. If required, either Arctic 7 or Arctic's UltraScale Plus families can be considered. If transceivers are not required, the decision point then becomes one of price, logic resources, and I/O to logic ratio. One final consideration may be the end application. Many edge applications require a compact form factor to comply with the size, weight, and power requirements. As the programmable logic device is at the heart of this system, size-constrained applications can benefit from smaller footprint devices. If this is driving the selection criteria, then a device in an integrated fan-out package may be the best choice. To help get started with understanding more of the benefits of the cost-optimized portfolio range and how to go about selecting the most appropriate device, Aduvo has recently released a white paper which presents the cost-optimized portfolio, the selection criteria that can be used to help narrow down and focus in on the most appropriate device. And we also provide several guided case studies and examples to help guide you in that selection criteria. So please take a look at the white paper, and if you have any questions, please reach out and let us know. Thank you very much.